Completed a whole chapter on the basic fundamentals of probability, and now you've spent some time looking at advanced counting techniques. So in this lesson, it's time to just bring those two things together. A bit of revision: the probability of an event is just the number of items in the event space, or in other words, the number of favourable items, over the total number of items in the sample space. So in this exercise, we really just need to be careful to use our counting techniques to come up with both that numerator and denominator. Now, things to think about: you'll need to consider whether or not the selections are ordered, and if they are ordered, can the items be repeated? And another tip: some of these questions can be answered by treating the selections as though they're ordered or not ordered, and then making up for whichever way you went. But if you've got a choice, I recommend treating them as not ordered is generally easier. And the reason for that is there's no potential to make a mistake with considering the number of ways you can order the items, but also the calculations are generally just using smaller numbers, and that's because the NCR formula has smaller numbers on the denominator. This is a good example because it involves ordered selections and unordered selections, and I'm going to do both questions in two different ways, just so that you can see that there's quite a lot of variety, and you can come up with a way that is easy for you and makes sense, but also one that's less likely to lead to errors. So 3 cards are dealt from a standard pack of 52. Find the probability that 1 club and 2 hearts are dealt. Now, firstly, we've got to think about them being dealt in that order: the club first and then 2 hearts. And then secondly, we have to think about what are the chances of them being dealt that way in any order. Now, we've learned our fancy counting techniques that use the NPR or the NCR notation. We've also learnt that in probability questions, acting out the question or imagining acting it out is quite a good strategy. So I'm going to look at both questions with both methods. Now, method 1, using our fancy counting techniques, if we're looking to get these cards in that particular order, it makes sense to say, well, how many different hands could we be dealt that are favourable? So we're literally looking for the number of ways that we can get what we want, or the number of items in our event space. So we want the number of different hands that we could be dealt that is a club and then a heart and then a heart. Well, how many clubs are there? There's 13. So for each of those 13 clubs that you might get, there is another 13 hearts that you could get when you get your first heart. And then when you get your second heart, there's 12 of them left, so there's 12 more combinations. So the number of hands that would be favourable would be 13 times 13 times 12. Now to consider our sample space, which is the total number of ordered hands that we could get when we're getting 3 cards out of a pack of 52. So the quick way to think about that is that it's 52 P3, because we're wanting them in a particular order. Now, don't forget that 52p3 is really 52 factorial over 52 minus 3, which is 49 factorial. So effectively, if we unroll the top, we've got 52 times 51 times 50 times 49 factorial, and the 49 factorials cancel. So we've effectively got this in our denominator. Now you can think that through and put that in the denominator, or you can let your calculator do the work and just put, I'm doing a particular order, so it's 52p3, and you can chuck it in your calculator like that. And the answer will come out as 13/850ths. With these sorts of questions, if you can leave your answer as a fraction, do so, because that way it's exact and you're not having to round it off to a certain number of decimal places. So if we're thinking of this other method of acting it out, well, it's not too different really in this case to say, well, what are the chances that I'm going to get a club when you deal me 1 card? How many clubs are there? 13. How many cards are you dealing from? 52. The chances of getting your club is 13/52ths. Now you're wanting to get a heart. How many of them are there? There's 13, and there's only 51 cards in the pack, so the chances of that, 13/51ths. And then there's 12 hearts left out of 50 cards, so it's pretty easy to see that this acting it out method is quite good for this question. Either method here, I would say, is fine, whichever one makes most sense to you. And you'll notice that when we're multiplying fractions, this is, of course, exactly the same as writing it this way as one giant fraction. And so you can very quickly and easily verify that what you've put on the top with either method is exactly the same thing, and what you've put on the bottom with either method is also the same. So it makes sense that your answer is the same. Now, I'd say either of those methods is good for that sort of question. All right, what about getting those cards in any order? Well, if you've already considered order, and you've already got this answer, then it does make some sense to consider putting order into a question that doesn't have any. Because you might have already worked it out and said, well, there's 13/850ths of a chance that I get them in that order. So now all you really need to do if you're thinking of this method of acting it out is to say, well, let's now take the order out of it. How many different ways could I get one club and two hearts dealt to me? How many orders are there? Well, there's two things that are effectively the same, and we're not too worried about them here. They're both hearts. So really the question is, where could the club come along? You could get the club first and then the two hearts, or you could get a heart, then a club, and then a heart, or you could get the two hearts first and then the club. So really all we're considering is whether the club is going to be given to us first, second, or third. So there's three ways that this hand can be given to us, and that makes it 3 times as likely that this is going to happen if we're not worried about the order. So if you've already got this answer, then thinking about the number of ways that it could happen and multiplying makes quite a bit of sense. On the other hand, if you're doing this question from scratch, I'd be more likely to use this method of considering the number of unordered selections, because it's actually a lot easier. If you go straight to this question, not having done A, and you do this method, the problem is that you might get this number wrong by, having difficulty working out how many ways there are to make your selection without the order. So this method here makes a lot of sense. It says, all right, let's consider how many ways that we could possibly get a club. Well, there's 13 clubs to choose from, so we need to have 13 choose 1, or 13 C1, and we know that the answer to that is 13. There's 13 ways you could choose a club. Next though, rather than considering the next 2 cards separately, let's consider them together, because if we don't care what order there is, we just want to know how many ways there are to get 2 hearts out of the 13 that there are. Well, there's 13 choose 2 ways to choose 2 hearts out of 13. So it makes sense that the number of combinations that you're going to get with 1 club and 2 hearts is 13 choose 1 times 13 choose 2. And on the bottom, the total number of ways that you could choose 3 cards out of 52, not caring about order, is 52 choose 3. Now, this notation is quite handy because you can throw this whole thing into your calculator like this, and the answer will just pop out 39/850ths. So if you're doing a question without order, I would recommend this method because it saves you from potentially messing up when using order and then considering how to take order out of the question.